Here we'll solve a rational equation. In order to solve a rational equation, we must first find the least common denominator. But in order to find the least common denominator, we have to factor all the denominators that we can. We might notice that we have only one denominator that is second power, that's this x squared plus x. If we look at what those terms have in common, they both have x. We'll factor that and rewrite it as x times x plus 1. This is what we'll get if we factor an x out of both terms. Now we look to our LCD. Our first fraction has x plus 1, which is a binomial. That will have to be part of our LCD. Our second fraction has x, which is a monomial. That will also have to be part of our LCD, and that'll be separate from the binomial. Our plus 5 does not have a denominator, so we don't have to include that. Our final denominator is x times x plus 1, which we already have in our LCD. Therefore, our LCD will equal x times x plus 1. Now that we know this, we will set the LCD not equal to 0 to find the restricted values. We'll say that x times x plus 1 is not equal to 0. If we split this into pieces, we'll say x is not equal to 0, and x plus 1 is also not equal to 0. This x not equal to 0 is already a restricted value. We don't have to do anything else to this because we already have 0 on the right. For the x plus 1 is not equal to 0, we'll now subtract 1 from both sides to solve for x, and we'll end up with x is not equal to negative 1. Now that we have our restricted values, we're going to multiply each term by whatever it needs to meet the LCD. Our first denominator is x plus 1. It already has the binomial, but it needs the monomial. Our monomial was x, so we're going to say this term needs x, and we'll say 3x over x plus 1, and then multiply by x on the top and the bottom. Our next term was 2 over x. It has the monomial, but it needs the binomial, and our binomial was x plus 1. Therefore, we'll say plus 2 over x, but we'll multiply on top and bottom times x plus 1. Our next term was just the 5. It has no denominator, so it will need x and x plus 1, both the monomial and the binomial. Therefore, we'll say plus 5, and then on the top and the bottom, we'll put x times x plus 1. Our last fraction after the equal sign already has both x and x plus 1, so it has the monomial and binomial. It's okay, and we don't need to change it. Note that it was originally written as x squared plus x, but in the factored form we can see it has both the monomial and binomial. This is why it's so important to factor before we try to find the LCD. Now it's time to simplify our numerators as much as possible. Note that we do not want to simplify our denominator yet, just the numerator. Our first fraction says 3x times x. 3x times x will give us 3x squared. Our second fraction has 2 times x plus 1. 2 times x is 2x, and 2 times 1 is 2. Our third fraction has 5x times x plus 1. 5x times x is 5x squared, and 5x times 1 is plus 5x. On the right side of the equal sign, we'll have just 3. There will be no change to that. Also in the numerator and denominator, this will all be over the LCD, x times x plus 1. You'll have the same on the right as well. Now let's try to combine the numerator terms as much as we can. We have 3x squared and 5x squared, those are both the same power, so it's okay to add them. 3x squared plus 5x squared gives us 8x squared. Then we'll look to the x terms, 2x and 5x. Together, 2x plus 5x makes 7x. Finally, we'll have positive 2, and this will all be over x times x plus 1. This will equal 3 over x times x plus 1. We'll do more with this on the next page. Now, when we are solving a rational equation, remember that our solutions come only from the numerator. We can find our solutions by setting the numerators equal to one another and trying to solve. Remember also that the denominator was only good for giving us our restricted values. We already found the restricted values on the first slide, and there's nothing else we need to do with that at this moment. Therefore, our new equation will say 8x squared plus 7x plus 2 is equal to 3. Notice that this is a second power equation, and for second power equations, we're going to want to get 0 on the right and everything else on the left. Therefore, we'll subtract 3 on the left and right, and now we'll have 8x squared plus 7x minus 1 equals 0. Since we have a coefficient in front of the x squared, we can use the AC method to factor this. Our a is positive 8 and our c is negative 1, and if we take a times c, we'll get negative 8. We'll need to think of two numbers that multiply to make negative 8, but add to positive 7. If we tried negative 1 and positive 8, if we multiplied those, that would make negative 8 like we want, and if we add, we get positive 7. That is a match for our middle term, and so therefore we will split that 7x into negative 1x and positive 8x. As we just said, negative 1 plus 8 gives us 7, so negative 1x plus 8x is still 7. We'll now put 8x squared and negative 1 into our equation, and now let's think about how to factor it. When we factor with the AC method, we don't factor everything at once, we factor them 2 terms at a time. Let's look to the first pair of terms and see what they have in common. We have 8x squared and negative 1x. The only thing those two terms have in common is that they both contain x. If we factor x out, 8x squared becomes just 8x, and negative 1x becomes negative 1. Our second pair of terms, 8x and negative 1, have nothing in common at all. Since there's nothing we can factor out, we will factor out a positive 1 instead. We'll say plus 1 times 8x minus 1. We'll say this equals 0. Then we will package this x and positive 1 into its own parentheses. This will give us x plus 1 in one parentheses and 8x minus 1 in the other. Now we'll set this equal to 0. If we solve the x plus 1 and set it equal to 0, we'll have x equals negative 1. If we do the same to this 8x minus 1, we'll say 8x minus 1 equals 0. Move the 1 over, we'll have x equals 1, and then if we solve, we'll have x equals 1/8. Now we'll compare our solutions that we found against the restricted values. Our solutions that we found were negative 1 and positive 1/8. We also have restricted values at negative 1 and 0. Our first solution, we can see, is also a restricted value. This means that x equals negative 1 would fall in a hole and therefore is not a true solution. Since that's a fake solution, we'll cross that out. However, that leaves behind our real solution of x equals 1/8. Note that 1/8 is not part of the restricted values, so it's okay. Therefore, when we answer this question, we would only say x equals 1/8.